Hey everybody, I guess we're going to start now. Before we get started, my name is Mark Doyle. I'm BIM Coordinator with Pomerleau. I'm here with Brendan Lawrence. We're going to give a cool speech in a hospital. Before we get started, I just want to share that we can't disclose what hospital this is, but we can disclose the process. So you're going to learn some cool things about this project that we're up to. Just to gauge the room, how many people in construction do we have? Put your hand up. Whew, a lot of competition. What about designers? Do we have any like architectural designers? All right, great. What about consulting engineers? Any students in the room?
Faculty.
Good.
Faculty's good, yeah.
So breaking this down a little further, how many people here use Navisworks? Wow, a lot of people. What about BIM 360 next gen? Just a couple. BIM 360 Glue. Not too many. That's what I thought. So we're going to give a presentation on how we use BIM 360 Glue on this hospital project. So let's get in
A little remote
here. So Pomerleau is a company that was started in 1964. It started off as 8 employees, and we made $18,000 in our first year. Fast forward to 1970, we built our first hospital in CFB about Cartier. Fast forward to now, we have 60 hospitals under our belt. This, I believe, is the first one using BIM 360 Glue on it. About 10 years ago, we started a small BIM department within our company. And over the course of 10 years, grew it up to about 30 people. And in the last year, something changed, and where it was changed into the innovation department. And the purpose of the innovation department is for us to be on the cutting edge of technology. And we've developed different research axes to really gain insight into what the future of construction is going to be. Things like interconnectivity, Internet of Things, robotics, AI, all that cool stuff. So we want to be ahead of the curve. Right now, we have about 100 projects that have been BIM. We have 40 that are currently in construction, and our team is about 45 players, and we're growing. So we really want to be the best BIM company out there. So that's a challenge. So a little bit about me. Again, my name is Mark Doyle, Senior BDC Coordinator for Pomerleau in Halifax. I started my career, I was a graduate of NFCC in 2006. I moved to Alberta and I started work in the architecture field. I later moved back home to Halifax. I worked for a multinational corporation doing consulting engineering, and then eventually got into construction. So I've seen a lot of the design world, and now I'm in construction, and I love construction. I'll tell you what I like most about construction, and that is that it has to get done. You just have no choice. You're at the end of the line, it has to be built. The other thing that I really like is that I don't have a CAD manager above me dictating my standards. And where that really helps is it gives me a lot of opportunity for creativity and flexibility and going just beyond. One thing that's really cool about our construction sites is that we don't have paper drawings anymore. We have everything's on our smart touch TVs and iPads. So we, because I have that, I don't have to rely on like people printing these drawings all the time, so I can be in color. So I use color a lot in my drawings. I use them in my models as well. I'm going to pass things off to Brendan now.
Yep.
And he's going to give us a little introduction here.
Yeah, so I'll introduce myself. My name is Brendan Lawrence. I've been working with Pomerleau for about 5 years. I graduated here from the University of New Brunswick in 2013 with a Bachelor of Science. I've worked with Pomerleau for 3 years, worked for EXP for 1.5 years, working on the consulting side, and then returned there about 2 years ago to begin work on this project. So in my time there, my experience was I worked on the St. John's Convention Center, at which time I was the BIM coordinator for that particular piece. So I spent about 9 months doing full mechanical, electrical coordination drawings. So that was my introduction to Revit and to 3D coordination. From there, I've done the commissioning of a water treatment facility in Newfoundland. I built a design build project, hockey rink, which we again use Revit. Sorry, my voice is a little off, but and then right now, currently, we're working on the hospital here in New Brunswick. So that's that. So a little bit about the project, guys. We've got a construction duration's 4 years on this, so it's a long-term project. We had a little bit of time up front to do a bit more planning than we typically would with a smaller, shorter duration project. It is a stipulated price contract. It's a multiple phase expansion and renovation. So currently we're doing the expansion portion of the project, and eventually we will be making the connections between us and the existing operational hospital. It's a very highly technical design, as you can imagine. It's a hospital, all the systems that are involved, from pneumatic tube, and Mark will take you through all the models. One of the tricky parts of this project that made it extra technical or extra difficult is that the levels were matching the floors of the existing building built in the 1970s. So we had very confined ceiling spaces. We had to bring the current building up to code. There's a lot more ventilation, a lot more electrical, everything to meet the current standards. So it's a 6-story building plus the basements. We have 7 floors total, and level 3 and 6 are complete mechanical rooms. So some of the technology that we used on this project, we used BIM 360 glue, which Mark is going to go a little more in depth on the technical portion of. We use BIM 360 Field for issue tracking and all of our checklist inspections. We use Smart Use for our digital plan board, which we track all the PCOs, RFIs, changes throughout the project. We use Holo Builder to document the system and process, which is basically a 3D camera where you can point and shoot. So we do all of our above ceiling inspections, wall closing inspections using that system. And then Mark is going to sort of go a little more into the model slicer portion of that as well. So one thing I wanted to talk about was right at the startup, where were some of the issues that we ran into? Where did we have troubles? What were the hurdles that we had to overcome with the subtrades, with the partners, in order to get this off the ground and running? So one of the contractual issues is that, again, as I mentioned, this is a lump sum project. The requirements for BIM were removed at the time of tender, okay? So this meant no one had any contractual requirements to become involved with the 3D modeling process. So the solution to that was that we had multiple discussions at the beginning of the project, speaking with all the groups, all the main trade partners involved. How are we going to do this? How are we going to coordinate this? We were all aware of how technical it was and how confined the spaces were. So it was multiple conversations, and eventually we started to get some buy-in and input. So the other issue that came about is subtrades not being aware of it. Where are the risks allocated in dealing with this? You know, what level of accuracy is already provided within the IFC model? And what are the inherent risks with modeling or changing something that was given to us and stamped by an engineer? So part of the other issue was understanding the responsibility and constraints when making modifications to that, like I mentioned. So the solution was we submitted a complete coordination drawings as we completed them to the consultants for their final review and sign off. This gave us the reassurance that what we were doing and the modifications that we were making were still in conformance with the original design. And then we also submitted clear and concise project guidelines to the subs so that they knew what their constraints were, what they were allowed to do, what we had to request for clarification or information on, in order to help define sort of the roles and responsibilities and what we can do with the model and what we can't. So the technical issues that we ran into is a lot of the trades didn't have experience using the system. Some of them did, different levels of use, different practices that were used. Sometimes it was small areas that they would model in order to make sure that we could make the systems work. So what we did is we did multiple training sessions with these groups. Right from the get-go, we started weekly meetings, which we'll sort of dive into a little later, but just making sure that it was always on the people's minds, that it was always progressing. You couldn't let it stay stagnant or else it would fall apart and die, right? So the next issue was verifying the accuracy of the models that were supplied by the consultants. So when we stepped into this was a phased construction project. Exterior cladding and envelope was done under the previous phase. We came in to do the interior fit-up portion of this building. So what we had to do in order to solve that is we did a full 3D scan of the existing building. We collaborated with the previous contractor who supplied the IFC model for the structural steel, so which was actually what they used to design and facilitate their shop drawings. So when they provided that to us, we did a full 3D scan of the existing structure. We verified, cut sections, made sure that the steel was where it was supposed to be. If we have something good at the beginning, we had something good to build from. So the fact that we had this verification process, it certainly helped with reassuring all the parties that this was going to work. So a little bit about the 3D point cloud. So we self-performed the 3D scan of the building. We generated the point cloud ourselves. We have a team that does this for Pomerleau. So we brought them in. They're from the Quebec branch, I believe, or Montreal branch. They came in, they scanned the entire building in the course of 3 days. They generated a point cloud within 3 days after. We incorporated that into our model and began doing basically slices. I think there was hundreds of sections that were cut through. We were verifying tolerances of the steel. We were verifying slab thickness or slab flatnesses because we didn't pour the slabs. We wanted to make sure that they were done well. Oh, did I do something here? I'm not clicking. Oh. So that point cloud was used to verify, like I said, and it was used to determine slab flatness. So what we did is we actually heat mapped every single floor, and then we overlaid this onto a regular set of drawings. We were able to see if there was a discrepancy between the floor flatness and figure out if it was going to affect our doors, whether or not we were going to be able to seal them, different isolation rooms in the hospital, different places all throughout. So we were actually able to, it's rather interesting, we cut a section about 6 inches from the bottom slab of the model to review where all the steel was on the IFC drawings versus where the steel actually was. And we were able to determine that, an inch tolerance or a 2-inch tolerance here, but we were governed by our corridors. So we were actually able to RFI and relocate the corridors to make sure that they were straight in advance of us actually doing all the framing and building, putting our top tracks in, spraying applied fireproofing. So we were able to make these slight adjustments, which saved headaches down the road by simply being prepared and verifying the data that we were given. Okay? So this is you, Mark.
That's me, yeah.
Yeah.
Thank you. Thanks, Brendan. So I'm going to talk about breakdown of the project, breakdown of this model. There's a couple of reasons we want to break down this hospital. A, it's a huge building, and B, the end result is that we're going to have people on site, trades using iPads. And the last thing you want is one of these models crashing on an iPad. If it crashes on the iPad, your whole coordination game is over. Nobody can use your model. So we decided to divide the model up by levels. And then we decided to, or not decided to, but it was set up in we had different zones per level. And you'll see it here. Get into this. The different levels here. And this lets us, we broke down the model into bite-sized chunks that are easy for people to consume. And yeah, broken down by level and by zone. So yeah, design models supplied by consultant. So we were very fortunate that the consultants had the foresight to use Revit and to really put a lot of effort into creating great models for us. And we got a lot of good models. We got architectural. One thing you'll see here, the color. We use color here to identify the different the fire ratings of walls. So you can visually see them rather than having to go through a drawing and try and pick it up. We got fire protection here, plumbing and reverse osmosis, and you start to see it's getting really congested in here. Heating and cooling, pneumatic tube, which Brendan's going to get in and tell you about later. We had some interesting, cool challenges with that. Ventilation, now you start to see where this comes in. And now this is our level 3 model, and that's where I'm going to focus most of my time today, on level 3, because it's the most congested space. And we have medical gas, and then we have electrical. We only got cable tray for the model. We didn't get any conduit. And there's a trend that I'm seeing in industry, not just on this project, but almost all my projects, is that between consultants and between electrical subcontractors not wanting to model conduit, thinking, oh, well, it's not really that important. it's just something we're going to throw in. So, just let us do our thing. We saw the value in modeling it. And if you look here, like when we got the model, this conduit was not in here at all. And so we said, we got to get it in. We put it in, and you'll see the ducts here, they actually come down. They didn't do that on our original model. We had to coordinate that in. And that space the actual level has no tolerance at all for any error. I couldn't even give that much away to anybody. So it was through having this and putting it into the model that we were able to achieve the efficiency here. And structural. So as you can see, really, really complex space. So the goals of coordination. What are the goals of coordination? To produce a coordinated model. This is quite obvious, but there's a couple things we did. So we focused on the coordination on really congested areas first. Now when I do clash detection, the first place I go is structural. I clash everything against structural because structural is a constant. It's not going to move on you. It's very rare it's going to move on you. And so when you find all your structural problems, then you know what you really have to focus on after that. Once done structural, I focus on big ticket items like HVAC. Getting the HVAC all sorted. And you can see here, all the HVAC is color coordinated. So we have yellow is supply, return is purple, cyan is exhaust. So visually you can see what's happening in this model. Identify and resolve conflicts before realizing them on site. One example here is we had fire protection was actually about this high, and then we had duct on top, a big duct about this big in the model, and then there was 2 water pipes above it and the structural steel. And the problem that we had is the fire protection guy was saying to the duct guy that your system is interfering with mine. This is really problematic. And eventually it came to me, I got the issue, and I looked into it, and we realized that in the model, somebody didn't model the insulation for those 2 little water pipes above. And that pushed the duct down into the fire protection. So we were able to identify that and solve it, reroute the water pipe. And it turns out that the fire protection pipe was never in the way of the duct. So people started starting to trust this model. And that's where the real trust started. That happened early on level 3. And now everybody has a lot of confidence with that level. That provides a better form of communication with the trades. Trade models use prefabrication. So I think this is like a legacy thing that comes from the AutoCAD days, but it's making not modeling something that should be there and using the details to sort of cover off not modeling that. And one such thing was steel platforms for access for all the fire dampers. So this was represented by typical details of what steel will look like when you get to that part of the project. And so we thought, well, we're coordinating all the fire dampers anyways, and it's a really congested space. It really makes sense for us to model that, get it in, really reserve that piece of real estate in the model for the structural prefab there. Produce coordination drawings off that and have shared them with the sub. So I'll show some pictures of that a little later. The other thing we did was ensure access for maintenance and compliance. So there's maintenance pathways going through this level 3, and we decided to build a box, like an airspace, and clash detect against it. And we didn't allow anybody to go through it. And if you touched it, you had to move your system. So what's really cool on site when you're walking through these hallways, like it's a wall. It's really flat. There's nothing poking through that little, into that corridor. Really, really cool. So models that we supplied, we ended up supplying a number of models to this project. The first is medical booms and lights. This is kind of a good way to utilize families in Revit. Just a real simple family where I had one family representing all five. I think we had five different boom types. So one family to make it work, and like just being a little more creative, put the model text of what drawing to look at to see that thing. So I like to make a model visual so people can walk through it. I know that at the end of the day, some of the people using this technology, and even on our project, it was a lot of people that had never used this stuff before. So I don't want them to have to go back to their trailers and try and find a drawing, or go into the digital drawings to try and find some information. I want to put that in the model if I can. So I threw the text into that family so people can find information. Here's a picture of the access platforms. You can actually see that off on the end here, that would be kind of custom. That wouldn't be, you wouldn't really find that on a typical detail, but that's what that had to do there. So now they know about it, they're aware of it, they can build it off-site, and it'll be efficient. Again, using the text through the stairs so people know what it is, where it is. You can also see that we had space for the fire dampers, so we could, that access space, we incorporated with our clash detection so nobody would interfere with that space. Again, one of the coloring the walls there, we knew that we could easily visually identify what the fire rating was on the wall with the color, but also see where the dampers needed to be. And through this process, we were able to discover some walls that didn't have fire dampers. So it's a good catch. Next up is head walls. So our shop drawings were not approved at this point, but we had the rough idea of what was going in there. And so we modeled what we knew, and we threw some access space on the head walls, threw them all in, and that allowed medical gas to, again, reserve their space in the model or claim their real estate. So what is BIM 360 Glue? BIM 360 Glue is a communication software. It's also a visualization software. We use it for clash detection, but mainly, and site measurement verification, but mainly it's a way for all the trades, everybody on the project, to see the model. It's very similar to Navisworks, but it's with like less than half the features. So all you guys that are really familiar with Navisworks and love Navisworks, probably not going to like Glue, because none of your tools are there. None of your quick keys are there. It's actually quite frustrating as a person who spent most of their career in Navisworks to jump to this. You lose a lot of the functionality, but I think the real payoff is what you can get and give to the trades, and how they can really access these models. So, need a drink. So a little bit of the technical setup for the model. Again, we had a lot of trades that were not really familiar with the BIM process and what to do. So I set up a lot of their models for them. I didn't see the value in making them, like giving them a list of all the things they had to do to start up and start working with us. That just didn't seem valuable on their end. It seemed like a waste of time. And I knew that if I asked them to do this, it probably wouldn't get right the first time, and I'd have to troubleshoot them. And there's 8 different disciplines, and I got to troubleshoot. Like, just the workload would go up. So I just said, give me your models. I'll take your models. I'll set them all up. I'll add all the views that are necessary. Glue relies on export views, very similar to NextGen. So I have the export views for every level. Now, we're talking about a lot of views that I have to generate. So there's some cool tools that I got here to set it up. And the first one is the DPR model slicer. I don't know if anybody's ever heard of that. Anybody? So what that does, it's a tool that allows you to make 3D section views of levels. And it references different datum, or the different datum references in your model. So you can actually cut on the level. You don't have to eyeball it to the level. Sure, it's, I don't know, you can eyeball it, but you could just set it up in this one box, and then it'll create all your views for all the levels. So that's really handy. But then you got the next challenge of, okay, I got the 10 views created for the 10 different models, but how do we get that in the other files? So Pomerleau has developed a really cool plugin that you all should write down and download because it's pretty cool. We don't get any money for it, but it's a really cool plugin where, so I've set up all my views in the architectural file. For example, I open up the structural file, I link in the architectural file, I hit the Pomerleau plugin, it allows me to go into the architectural file and download all those views and puts them into the structural file. So it's just one click done. Just have to rename the views. So it's a really cool tool. We developed it when we built a 22-story building in Halifax, and we had, again, architect had about 30 typical units, and I actually worked for a different company at the time, and Pomerleau did this for our company on the job. So that was really cool, like a company stepped up for us and developed this so we could get the advantage of getting the efficiency within this model. So like 50 units or 30, 50 units typical throughout the entire project and all the various disciplines, that's a lot of views to make. And that has to be done manually with tools out of the box. So this Pomerleau Transfer View plugin really saves a lot of time. And I would recommend that you get it for your project. So yeah, use that, that's how I created all my views. Then went and used the views, created the glue model, and again, prepped the trade models, and then using color coding, color-coded all the systems within the building. So now trades can, once they learn the colors, they can learn the systems. Also, with respect to colors, I've decided to share all my colors with everybody. I sent an email to CanBIM, and so I have an Excel file that's somewhere you can get, and it has all my colors. And it's one of the things that, like, I could be up here and say, yeah, they're all my colors, and I'm not going to share them with anybody, but I think as an industry, getting standardized colors that work really well for us is something that we really need. In my model, there's a couple colors you won't see. You won't see red, because we normally find that around clash detection. And there isn't bright green. Bright green is a really good selection color. If you're not using bright green, try it, because it really, amongst all of this, even all these bright colors, you can see bright green. It's very easy. We have some other really cool tools at Pomerleau. I added these 3D text to all the room names. So Pomerleau, being an innovative company, we have some software programmers. And so when I have a problem, I just call up Montreal, and I get a software guy. I need a plugin. I need it to do this. A couple days later, I get a plugin. It's really cool. So he developed me a little plugin that just converts all the room tags to room names. And we put that in. Really handy tool. Now, trades on site know all the rooms. You don't have to flip through anything. So again, bringing that visual into the model. We use box.com for all our storage. Box is kind of handy as a Revit person. You can use this thing called Box Sync to your computer, have all the models saved there, have people uploading every day, and you can get that download and view it as your LinkedIn files in Revit. Really, really handy tool. Something's happening here. So, executing the coordination process. Can anybody tell me what the worst thing about clash detection is? What's the worst thing about clash detection?
Too many.
It's the clashes. There's too many clashes. As a BIM guy up here, I can be like, I can use my ego and be like, yeah, I worked on this project and I got like 90,000 clashes. Look at me, I'm like, I found all the clashes. I don't have them.
No, they're good.
But it's the clashes. There's too many clashes. I'm working with a brand new team, people that are brand new to this process. Last thing I want to do is overload them with 10,000 clashes. This is the last thing I want to do. So glue is really cool in that it gives you, when you run a test, it gives you this massive list of clashes, but it gives you dots. And these dots, you'll see them in this image, there's dots everywhere. And the beauty of this system is Now we can see where the problems are. From here, I just create a snapshot. And here is one clash, one thing interfering with structural. It's actually a heating pipe. And there's 7 clashes. So that 7 clashes is represented by an image. We take these snapshots of all the images that or all the issues that we find, take snapshots, save them. We put them into Excel just to track them. And I want to ask, how many clashes do you think, or we call these issues, how many issues do you think we had in this project?
Soft or hard?
What's that?
Soft clashes or hard clashes?
All classes.
1,000.
1,000? We had 2,500. So what this works out to actually be is about 10 to 20 clashes per week per trade. So it's really small. They can consume this. We can get stuff done. Listen, jumping a little bit forward here, we use Power BI to visualize our data. It's a good little tool. Somebody showed me once. So, so that's our process. I'm going to jump into just my closing slide for executing the BIM coordination process. I think the biggest thing I learned about this whole process is that you really need to have patience with the trades. Patience for the people getting involved. Like, it's easy to get frustrated, and if you bring that to the table, that frustration, it's going to bring the team down. And you can't have that. So exercise lots of patience. The more you can do early, the less you're going to do later. I think we all sort of know this idea, but the more prep that I did at the beginning, I knew the value of it was going to be later on down the road, the less that I'd have to worry about it. And this project is really cool. It's going together really well. I'm not getting a lot of BIM issues coming from it. There's very little BIM issues coming from this project. Brendan will tell you more. For the trades, even though I set them up and I did all the upfront work, I also gave them a document that showed them what I did. This is just a custom document for the BIM coordination process, separate of the BIM plan, just to keep them engaged into what they need to focus on. The little parts of the process that they have to do, they can learn. The last thing is, if I uncovered some new efficiency that seemed really good, but rather technical and just beyond their skill level, I would take their model and incorporate that change into the model. Like, one example was some very advanced coordination views that we've been creating for the level 3 coordination. Building these were kind of challenging, so I took on their models and just made all the views so they'd have them. But yeah, that's my part. I'm going to pass things over to Brendan here. He's going to get into more of the technical.
That's right.
Thank you.
So, excuse me, guys. So one thing we wanted to talk about is the frequency of the BIM meetings and the frequency, I guess, of the gathering of minds in order to get this process moving and have it working. So we would have a meeting every single week, every Tuesday at 10:30, no ifs, ands, or buts. We had the BIM meeting. So the BIM meeting would typically last about an hour total. So it wasn't a huge time absorption for any particular member. I personally participated in every single meeting. I think there may have been one that I had missed. Actually, my wife was about to give birth in the middle of one. But so what we would do every single time we would come in, we would review the list of clashes that we had previously identified. So the sequence, I guess, of our total workflow, I'll cover that first, is we would have the meeting, we would review the new clashes with the groups, we would submit that list to everyone. Everyone would have the 3 or 4 days to go in, complete their work. By Monday afternoon, everyone would resubmit their updated clash list to Mark. Mark would verify that the issues were corrected and basically give a check mark whether or not they were good. If anything was not reviewed or corrected by that next meeting, those would be the first topics that we would cover, why they weren't closed, whether it was we couldn't figure out a solution to the problem or we just didn't have enough time to get to it. We would look at that with the entire team. So every time in these meetings, we would have them in the Pomerleau trailer. We would have the electrician, project manager sitting down, as well as the electrical modeler. We would have, so the modeling group for every discipline was there, as well as the project management team who could actually make decisions on the spot. That was a big thing. It was decision making is what happened. So this was honestly one of the most beneficial, probably the most beneficial meeting that we had on site during the execution of this work. Every time we would go in there, we'd solve 15 to 20 issues before we were building it on site, before we had our foremans and our superintendents sitting there looking and saying, how do we fix this? Do we have to call the architect? Do we have to call the engineer? No, we can move a pipe 6 inches. We would do that on site anyway. So we were able to solve that. And this allowed the groups, like Mark had mentioned earlier, to prefabricate their stuff. The entire steam system here, the entire hot water system, prefabricated right from the get-go. And we've had little to no issues with the installation of that. So that was sort of the solution. Rinse and repeat every single week. Go through, find 20, 30, 40, 50 issues on a good week, and just continue the process all the way through. So Mark had said we had broken this floor down into each floor. Basically, we tried to break it down into wings because we had to follow the construction process as well. We had to make sure that we were giving the information to the guys so that they could fabricate and begin construction in a timely fashion to meet our construction schedule as well. So we were always sort of under the gun to get the sign off and get the completion of that particular level. So once we had hit that stage in construction where everyone was happy, everyone said, okay, the clashes are clear, everyone's good, what do we do now? So the next step that we've done is we basically had a document that went out that said everyone who was involved with the model is in agreement that at this current stage or at this current date that we're good. Let's go ahead. Let's start fabricating. Let's start building. Okay. So the intent of this was not to point fingers at anyone. It was to say everyone's done their best. Let's go to the next step. So what that triggered is it let the trades know what space they have so they can start working, start putting their hangers up, start roughing their systems in. And made the trades accountable to each other. We all were in agreement at that particular time when we signed off on this model. It engages the production of coordination drawings, which I had mentioned earlier. So once we produced the coordination drawings, each discipline would generate their own 2D set. They were uploaded to our digital plans board, and then we would submit that to the client or the architects or engineers for a final review just to make sure we didn't make any large errors within the system. So they would review that as a standard shop drawing, send it back to us, say that yes, we're in agreement, this looks acceptable, and then we would proceed with the installation and fabrication. So that was sort of the sign-off process. What we would do is we'd take that model at that point, export it to Navisworks, so we'd have a cataloged piece of that. So if anyone went in to change the model later, because we don't control, someone could go in there tomorrow and change a piping system on level 6, we catalog it so that if someone does make a change, then we can at least look back and say, well, you made the change and now you're interfering. So it's a timestamp is basically all we're looking at for this.
It's a nice record, and we did have to use it a couple times.
Yep.
So I have to track down an issue, something changes in the model. Where did that come from?
Yeah.
So handy.
So the other fun one here is, I just wanted to touch on this quickly, changes management. As you're going through the entire model here, you're obviously going to changes are inevitable. They happen on projects. They're par for the course. So what we had looked at is what are we going to include in that model? What is going to give us value back by including into this thing? So we looked at it and we decided major mechanical, electrical changes, obviously with these ceiling spaces, are going to generate value. We make sure that they're incorporated and that they're going to work. The next one was wall relocations, because if we move a wall, everything on this project went to the underside of deck. If we move a wall, it might impede on a piece of ventilation, it might impede on a piece of pipe that we would then have to change and modify. It helped us with the quotations, especially on my side when I'm looking at the scope of work. I was able to look at that, verify it in the model to see if they're changing a bulkhead location, how does that affect my ductwork in its current state and how I'm going to build it. So I was able to actually, we canceled a few of them because what was shown on the drawings did not make sense with all the other systems and trades that had to be incorporated into it. The other one we did was ceiling height modifications. So anytime we would lower a ceiling height or change a ceiling height, like I mentioned with the bulkheads, we would have to incorporate that so that when the model was looking, when the guys were looking at working in the model, that they actually had the correct ceiling heights and they weren't looking at something that was 2,700, that should be 2,600. Right? 4 inches makes a difference. An inch makes a difference in a lot of cases here. So with that, I just wanted to give you a couple examples. These aren't necessarily changes that were facilitated by the owner or changes that we identified through the modeling process, but we just want to give you a couple highlights of some of the issues we identified through the thing. So as Mark had mentioned earlier, we have the model platform. So what Mark had done is he realized that they weren't incorporated, went and modeled all the systems, and what this allowed us to do was actually coordinate the ductwork where it exited the shafts so that we could actually still meet the constraints of the structural design. So spacing requirements, legs, I don't know if you can tell, but we put these jogs in order to make sure that we still could access the fire dampers from the top. If that particular instance was built out here, square to that column line, it would have been right over top of the fire dampers and the system wouldn't have worked. So we were able to go through, it gave us a forcing check to make sure everything was going to work. Another part that we noticed too is that the heights of all the access platforms wouldn't facilitate the installation of the ductwork underneath. So we had to raise it, add a stair, add a handrail, because now we're above code height. So we were able to do that, and in addition, while we did this, one last thing is we found 3 damper access platforms that were missing. We didn't have access to dampers, so before the steel arrives on site, before the ductwork's fabricated and installed, before we had even really started working on the shafts in this particular area, we found the change, we identified it to the consultants, we supplied a drawing, which was sent back to us to quote, and we were able to facilitate the installation in a smooth process. We did the work. There's no point in duplicating the work for the consultants. I'm sure they were quite happy to receive a detailed set of drawings from us. And then, again, like we said, we sent this back. We had our steel guy quote it, and it worked out very well. The next one, this particular one was an owner contemplated change. There was a change in the pneumatic tube system from the client. This was level 3. This was the drawing that we were given at that time. So we see nice straight lines where all the clouds are. Perfect system, perfect world. This is what the system actually looked like. I know the drawing's not good here, but every single one of these blue circles is in an elbow that was in addition to the drawing that was submitted to us. So we went through this entire system, quoted the change, put in our time. We spent, this was right at the end, right when we finished coordinating level 3. I kid you not, we were a week away from everyone saying, we got off, we're done. This came in. PHS, Pneumatic Healthcare Solutions, did a phenomenal job modeling this system to avoid interferences with the other groups, and was able to realize, that the scope that was given to them to bid was not accurate of what was actually going to be installed on site. So in this particular instance here, we probably modeled it too quickly. We didn't have the change approved. We didn't have that, so we kind of went at a turn, but it was at a point where it was so critical within the process that if we didn't do it, we were going to be sitting on our hands for a couple of months, right? So had to make some judgment calls with what was incorporated, how we incorporated it, and why. So the next one here, again, Mark generated this drawing for the ceiling heights. We did all the modeling on level 5, realized we couldn't stub the conduit out of the walls underneath the ductwork. So we were able to go through, revise all the elevations, submit this to the client, and say, hey, are you okay with this? Yeah, site instruction, send it back to us. Okay, so this happened on 4 floors in the building. So again, Mark color coordinated for the ceiling heights, very easy to see, very easy to visualize. Okay, the last one, again, level 3. I know we keep talking about level 3 because we're proud of it. We made it work. I've had 3 RFIs on that floor, and we've been installing on it for upwards of 14 months right now. So it actually has the least amount of RFIs for the entire project. Okay, so this particular system here, what we realized is that the access platforms, or the access walkways, that we were given on the drawings wouldn't work. We couldn't maintain the heights, we couldn't maintain the ceiling. So Mark spent some time with the ventilation guys, with the plumbing guys, to find an alternative route, proposed the alternative route, sent it to them. They sent it back to us as a site instruction, and we proceeded with the work. So you can see I'm sort of developing a process here. We find the issues, we find a solution, and then we talk about it and make sure it works for everyone. Okay? So we did a lot of these stuff, a lot of these site instruction stuff. It was just coordination, working something out, finding a solution. Nothing worse than problem makers. You come to the table with something to discuss, and you typically get a better yield from it.
Can I ask a question?
Certainly.
How did you communicate with those problems? Was that an email? Was it through a log system? How do you document all of those conversations and the decisions for those changes?
For these particular ones here, the way I looked at it is if there was a major change or a pathway change or a modification like that, it was typically submitted through an RFI with the documentation. And then what I would ask is for them to provide formal direction back to me in the form of a site instruction. If there's no cost associated with it, we literally just changed a couple of pathways, moved them around. And then, so yeah, it was documented in writing that we said, can we do this? If they say yes, then okay, please you don't have to redo the drawing because the drawing's done.
Right.
Just send it back to me, and that's my sign off that you're in agreement with us proceeding with this direction. So it is a difficult one to communicate because when we go and we'll talk about the meetings, the only thing I would have preferred to see more in the meetings is a presence of the engineer architect. That was one thing that was lacking in our entire meeting. And if we had them for that 1 hour a week to sit there and help us make those decisions, would have saved them a lot of time, would have saved us a lot of speculation and changes, and it would have developed the entire project much faster. I mean, we had to make changes. Anything that we questioned during those changes may have resulted in an RFI if it was something above and beyond what we thought was typical. I'm not going to ask the engineer to move a pipe 6 inches. I would be asking him questions, and we got lots of questions out as it is. We don't need to clutter it with that stuff. So, all right. So, I want to talk a little bit about the project manager's role within this. We know we've got the VDC coordinators doing their work, who's actually facilitating the modeling. I think one thing that's critical for everyone is understanding the process. Like I mentioned earlier, I was fortunate in my sort of development of my career where I was sort of thrown into the BIM modeling side of things right up front. You know, go figure out the coordination drawings, learn how to use Revit, you know, work with the team in Montreal to develop something. And for me as a coordinator, I built it virtually before I got to build it physically. So I knew those drawings inside and out and backwards. It was a great process, and I was able to implement a successful strategy for a lot of those mechanical and electrical rooms. So it was very beneficial learning codes. So understanding the process from A to Z, where you are and where you're trying to get. Being able to properly define the roles and responsibilities amongst the parties. Everyone's got to know what they're doing. Support the BIM team. Support the BIM team. Support your BIM teams. I can't say it enough, guys. These guys are out there working. This is a process that works. It is value added without a doubt. The management needs to support the BIM team. So it's like anything. You support your coordinators, you support your superintendents. You need to be just as involved with your BIM team in order to make this process work. Okay? If you put it to the wayside and expect someone else to go in and push the sub-trades and work that way, you're not going to get the end result that we achieved here. So be involved and push the groups. Help trade partners understand the benefits. So what we did at the beginning of this as well, like I said, it was sort of a sales pitch at the beginning to get everyone involved and to use this process. But we also had to show them what the benefits were. So we were able to sort of show some of the systems that they can use for prefabrication, that they can use for takeoff, that they can use for the CNC in order to further their value in buying into this system. And I guess I mentioned that last one there, attend all BIM meetings. So the results. So for this project, we definitely realized accelerated installation process. As I mentioned, that level 3 area, we have 3 RFIs for the entire thing. So if you were to compare that to any other floor in the building, there's substantially more, but this has been the smoothest. I thought it was going to be the most technical part of the project. It is the most technical, but I thought I was going to spend the most time on this, getting it coordinated. Because we did the work up front, we don't do anything on it now. I don't even look at level 3, to be completely honest. Reduced RFIs. I say reduced RFIs. It still generated RFIs. It certainly reduced a few of them, but it allowed us to do them so far in advance that it really didn't have an effect on our schedule or critical path. We were able to resolve these well in advance of when we were doing the actual installation, which inherently reduces delays. Okay? It reduced waste because, again, we're using prefabrication systems, and it minimizes rework, which is also a generation of waste. So a lot of these systems, I gotta say, like conflict resolution on the site, if you walk up and someone says, the first few times we're walking there, his pipe's in my way. And he'd be like, no, his duct's in my way. And this is a conversation we are all familiar with on a construction site. So normally it's first come, first serve. I was there first, that's my space. Complete game changer. And changing that mentality, once we got the models moving, maybe took a month and a half. Because we would walk up there for those first 2 instances, we'd pull up in the model, we'd take an elevation on it, we'd look at it and say, why is your pipe in the wrong place? And he'd be like, well, I'm not, I'm going here. No, you're going up and over. And done deal, no ifs, ands, or buts, pipe gets cut out, duct gets put in, done. So we started doing that. We did that probably 5-6 times, and I don't do it anymore. I don't spend that time. I spent that time up front in these BIM meetings solving that. So now I don't have to do that. The subs look at it, they've got a 55-inch flat screen on level 3, The guys go up and look at it together. They take a couple measurements. All right, I'm in the wrong place. Move your stuff. So the benefits: immediate interference and conflict resolution, which I just discussed. This allows us to track our coordination efforts. So throughout the whole process, Mark has a master spreadsheet which has basically allocated each of the issues, what was done to correct the issue, and who executed that part of the change. We're allowed to generate coordination drawings. This is, I understand generating a plan view set of drawings is great, that actually works. But what we're able to do too is also cut down and create the information that the installers actually need to do that. We're not going back and asking for dimensions on this and locations of that in these drawings. Those RFIs are null and void. We don't care what the original ones had, really. We're following what we had designed and what we built. So the guys are able to take and isolate their particular systems, isolate the supply system on level 3 and isolate the exhaust system on level 3 and provide all the information that he solely needs in order to build this and supply that to his workers. Because we do work off the coordination drawings and also use the model. There's too much information to pull every dimension from the model, but get the bulk of it, and this is just used to verify locations. Optimized routing of system is another benefit that we've seen. We're able to straighten out ductwork. We're able to find shorter routes for different systems, which is obviously a cost savings that can be realized by each of the parties. I'm not going to say it was tremendous on this because there was, again, it's a congested area. There's a lot of fittings. There's a lot of elbows. But we were able to optimize some of the routings for the sub-trades. Accurate takeoff and identification of extra. I know you guys are probably all familiar with doing takeoffs in Revit. You cut it at the bottom, you cut it at the top, how many elbows and fittings are in it. Well, you take your base model and you take your current model. It doesn't leave much speculation at that point. So we've used that on a couple of occasions to help justify our claims. Identify and maintain clearance requirements for equipment. This is something, again, that's critical, making sure that the area is accessible, that we can do maintenance, that the client, the end user, can actually operate this building safely. And finally, simplified communication. Further to your question, we were actually able to work with the mechanical engineer on this, and he was actually invited to use the model to go in and verify certain instances or clarify certain changes using our system. Not as easy to document when they just go in and look at the model, but that's how we did it. Better communication, it's better relationships. The more we talk, the better we can communicate, the less we have issues and the less conflict throughout the entire project.